Discuss redo and undo operations and the recovery techniques that use each. We have recovery is performed using two basic actions: undo, roll back; redo, roll forward. Different recovery technique use one or both of these. Redo operation, roll forward, reapplies an update or write operation of a transaction to the database. Use it to bring the database up to the state it had when the transaction is committed. Ensures that committed updates that may not have reached the database before a crash are applied. Implemented using the log TIX old new. Redo writes new value of X to the database. Then undo operation, roll back. Reverses the effects of an update of a transaction used to remove the effects of transaction that did not commit, incomplete or aborted at the time of crash. Implemented using the log in reverse order TIX old new. Undo restores old value of the X in the database. Recovery techniques and the operations they use. Recovery technique, deferred update. Use redo only. Description: all updates are recorded in the log. Actual database pages are not uploaded until it committed. After a crash, only redo is needed to apply committed updates. Immediate update, undo or redo. Uses undo and redo. Database may be updated before commit. After a crash, undo removes the effects of the uncommitted transaction. Redo ensures committed updates are already reapplied. Shadow paging uses redo only. Updates are made on shadow pages. On commit, page table is switched. After a crash, old pages remain valid. Only redo of committed transaction is required, if any. Undo versus redo. Purpose: to reverse effects of uncommitted updates. For undo, to reverse effects of uncommitted updates. Redo, to reapply effects of committed updates. When used during rollback, recovery of losers. During recovery to bring DB up to date. Order backward using log from last to first. Forward log for redo from first to last. Effect: restores old values, writes new values to DB. Ensures atomicity, durability. Then, what is a schedule? Explain serial, non-serial and conflict serialization schedules. Schedule is an ordering of operations: read, write, commit, abort of two or more transactions, such that the order of operation of each individual transaction is preserved. Types of schedules. Serial schedule. The operations of transaction are executed one after the other. There is no interleaving of the operation. Non-serial schedule. The operations of the transactions are interleaved. Conflict serialization schedule. The non-serial schedule is conflict serializable if it is equivalent to some serial schedule with respect to the final outcome. It preserves the order of all conflicting operations. Example: consider two transactions T1, read of A, write of A, read of B and write of B, commit. T2, read of A, write of A, read of B, write of B and commit. Serial schedule: T1 followed by T2. Serial, it will be like R1 of A, W1 of A, then whatever is there in the series it will do like that. C2. But here in the non-serial schedule we have R1 of A, R2 of A, then W1 of A, W2 of A, R1 of B, R2 of B, W1 of B, W2 of B, like this. But in conflict serializable schedule, you have R1 of A, W1 of A, R2 of A, W2 of A. Then W2 of A, then R1 of B, W1 of B, like this. R1 of B. A's, all A's are together and all B's are together here. Procedure graph will be like equivalent T1 to T2, no cycle, conflict serializable and equivalent to serial order. T1 to T2. Here explanation is all operations at T1 are completed before T2 starts. This is serial schedule. But here in the non-serializable schedule, the operations of T1 and T2 are interleaved. This is a non-serial schedule. And conflict serializable schedule. There are conflict example W1 of A before R2 of A, W1 of B before R2 of B. The precedence graph has no cycle, therefore it is conflict serializable and equivalent to serial schedule T1 to T2. He points two operations conflict if they are from same transactions on the same data item and at least one of these is a write. A schedule is conflict serializable. Its precedence graph is acyclic. Every serial schedule is conflict serializable. A non-serial schedule may or may not be conflict serializable. This is the deeper explanation of concurrency control and recovery method. Concurrency control and recovery are needed to ensure the correctness, consistency, and reliability of the database in the multi-user system. To ensure isolation between the concurrent transaction, to maintain consistency of the database, to preserve atomicity and durability, to recover the database to a consistent state in case of any failures. Problems that may occur when two transactions run concurrently. Consider two simple transactions T1 and T2 accessing the same data. X is x minus 100, x plus 100 for T2. Problem, loss update problem. The update made by one transaction is overwritten by another. T1 reads 1000, T1 reads x of 1000, T2 reads x of 1000. Update of T1 x equals to 900 is lost. Final value should be 1100. T writes only the end value. Dirty read uncommitted dependency. A transaction reads data written by another transaction that has not yet committed. T1 writes x of 100, x is equals to 100. T2 reads x is equals to 900. T1 aborts. T2 has read an invalid dirty value. Database may become inconsistent. Non-repeatable read. A transaction reads the same data item twice and gets different values. T1 reads 1000, T2 writes 1200, T1 reads again 1200. T1 gets different values for the same data item. Phantom read. The transaction re-executes a query and gets a different set of rows due to another transaction's insert or delete. T1 selects all rows where balance greater than 1000. T2 inserts a new row with balance greater than 1000. T1 executes the same query again. T1 gets phantom rows, new rows that appear or disappear. To avoid these problems, DBMS uses concurrency control techniques locking, timestamp ordering, etc. Recovery technique, log-based recovery and all. When deadlock and starvation problems occur, how these problems can be resolved. Deadlock. Deadlock occurs when two or more transactions are each waiting for the resources that is held by another transaction in a set, so that none of them can proceed further. Conditions for deadlock is Kaufman condition, mutual exclusion, at least one resource is non-shareable, hold and wait. A transaction hold resources is waiting, no preemption, is waiting to acquire additional resources, hold and wait. No preemption, resources cannot be forcibly taken away, they are released only voluntarily. Circular wait, there exists a set of transactions such that T1 waits for a resource held by T2 and T2 waits for one resource held by T3 and Tn waits for resource held by one T1. How it can be resolved is deadlock prevention ensures that at least one of the above four conditions deadlock never held. Then deadlock avoidance will locate resources only if the system remains in the safe state. Bankers will call deadlock detection and recovery allow deadlock to occur, detect it, and recover by botting one or more transactions and preempting resources. Ignore the problem used in systems where deadlocks are very rare. Starvation, indefinite postponement. Starvation occurs when a transaction waits for a resource for an indefinite time because other transactions keep getting priority over it. How it can be resolved? Use fair scheduling. Ensure every technique transactions gets a chance to proceed. Aging. Increase the priority of the waiting transaction gradually with the time. FIFO queue for waiting transactions. We have already discussed about the shadow paging as well as two-phase locking. If you have not watched the previous videos, please do watch and come.
ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಮತ್ತೆ ಸಿಗೋಣ. ಅಲ್ಲಿವರೆಗೂ ಫಾಲೋ ಮಾಡಿ ಟೆಕ್ ಗರ್ಲ್ ಕನ್ನಡ.